Good evening, everyone. Welcome to the Innovation Hub at the University of Manitoba for Falling Walls Lab Manitoba 2026. Tonight is a wonderful evening to celebrate innovation and courage and possibility, and we're delighted that each of you are here. My name is Janine Carmichael. I'm the Faculty Specialist for Entrepreneurship here at the University of Manitoba, and your co-MC for the evening. And I'm joined by Lauren Bosk, Director of Research Services at the University of Winnipeg.
We haven't practiced our routine up here yet with the switching. We were inadvertently standing in front of our posters, which was lovely, but now that we've switched. Thank you so much, Janine. We are pleased again from the University of Winnipeg side to be collaborating with Idea Start at the University of Manitoba in a partnership to organize this event tonight. We are also pleased and excited to welcome St. Boniface Hospital Research to the organizing team in 2026. As we gather tonight, oh yes, absolutely. As we gather tonight, our thoughts are with the family, friends, neighbors, and communities that have been affected by the extreme weather. I know a number of people were hoping to be here but had to change their plans last minute, so we're very grateful you're here, despite kind of what might be happening just past those windows. This evening, we are gathered on Treaty 1 territory and the national homeland of the Red River Métis in Winnipeg, Manitoba. We acknowledge that these are the ancestral lands of the Anishinaabe, Anishinaabe, Ininiwak, Neheathawak, Ocetisaquan, Dakota Oyate, and Michif peoples. This territory is also a place of significance for the Denisoulane and the Inuit, some of whom have been living here for generations. Our participants this evening represent the campuses and research spaces of the University of Manitoba, the University of Winnipeg, and the University of Regina, which reaches to Treaty 4 and 6 lands. As we explore innovative ideas for the future this evening, we do so with the respect for all the treaties that were made on these territories. We acknowledge the harms and mistakes of the past and present, and we dedicate ourselves to move forward in partnership with Indigenous communities in the spirit of reconciliation and collaboration. To help us begin in a good way, we are joined by Elder Norman Mead, who will share a blessing over our time together. Norman was born in Bessette, Manitoba, but grew up in the Métis settlement of Manigotagan, an Ojibwe word for bad throat. This is where he went to public school until the end of grade 9 and attended high school in Bessette. During his early career as a laborer and full-fledged gold miner, Norman met Thelma Barker of Hollow Water First Nation and has 2 children and 6 grandchildren. Norman continues to be active in the community as an elder, pastor, and on various boards in the city of Winnipeg. He is also an avid curler and is the founder of the Aboriginal Curling League of Winnipeg. Welcome and thank you for being here, Norman.
I'm honored to come and open us with a blessing tonight and accept this tobacco in my left hand from her left hand. When we accept tobacco as a gift from Mother Earth, one of the medicines that we use for these occasions, and we accept it in the left hand, arm closest to the heart, connected to the heart. So what I offer a blessing tonight is from my heart to yours. In my blessing, though, I do want to acknowledge the young women that are going to perform for us over here. I would say daughters because they are like the daughters of each of us. And the hoops that they will use to demonstrate their skill. And of course, all of you women and men that are here, that spirit that you bring to us tonight. When we think about, which are the next walls to fall, that is really up to us, you. Research, innovative things, collaboration. It's about all of those things when we think of that. It's about putting all of our knowledge and our skills and our spirits together. But in my blessing tonight, I don't want us to forget Last night we were taught a lesson, I was, even at my old age, about the power of Mother Nature. When she speaks, we have to listen. We can do whatever we can as human beings. And I say being human. Use those words in the opposite or in the other way. Being human. That we have to give way to Mother Nature when she speaks to us. And so we bring tonight, these thoughts and this research that we've done. We bring that together in a way tonight that we will learn from that. And we are blessed by that research, blessed by the work that has gone into it. The walls will fall, but we have to bring the spirit that every one of us has in us as men and women. Bring that spirit. And we have to think about our health, the physical health that we also have been given as a gift. The mind, the mental health, and the emotions and how we feel about things. Walls will be brought down. They will fall, but not without those four things that come together in each and every one of us. The spirit, the mind, the body, and the emotions. And we have to achieve balance in all of those things that we do. And many times in my blessings, I will acknowledge, first the elders that we have among us that help us to understand these things. The women, the mums, the grandmothers that of this, what they bringing life into this world. And of course us men as support people, right? This is the spirits we bring. So my blessing tonight is that each and every one of us would know and understand that we are blessed to be here. We are blessed that we have the knowledge that we can share with one another. The one teaching that I had always wondered about, is wisdom and knowledge the same? No, it isn't. Our children, our young people come with wisdom. Little ones come with wisdom. That comes from Creator. Comes from Kitchi Manitou, the Great Spirit. Our knowledge comes from one another this way, lateral. That's the difference between those two. I want us to know tonight that the wisdom that you bring is so beautiful, that wisdom you bring, and the knowledge that comes with that wisdom. So I say, miigwech, merci for being here today, and I'm sure we will have a good evening and be blessed before we leave here tonight with your presence. Miigwech.
Thank you very much, Elder Norman. Now, would you please join me in welcoming the Mason Hoop Dancers, Kimberly, Charisma, and Nakaya, three proud Cree sisters residing in southeastern Manitoba. They have shared their award-winning hoop dance, storytelling, and cultural teachings at schools, festivals, conferences, sporting events, and major gatherings across Canada and the U.S., including the World Championship Hoop Dancing Contest in Phoenix, Arizona, and we are so delighted to have you tonight. Through their performances, they celebrate Indigenous culture, inspire understanding, and promote reconciliation. Please, let's give them a warm welcome. Kimberly, Charisma, and Nakaya, the Mason Hoop Dancers.
Hello everyone, Tansei, Anin, Buju, Mino Kisigao, Anosht. It is such a good day today. I want to start off by saying thank you to our elder, Norman Mead, for starting today in such a beautiful and good day. So thank you for him sharing our wisdom. Let's give him a round of applause again. We are so excited to be here for the Falling Walls Lab finale of 2026. We're very excited to be presenting to each of you, such inspiring researchers, our cultural hoop dance. So we really appreciate what you're doing as you're making the path towards reconciliation more normalized. You're bringing together diversity and you're inspiring collaboration, which is really important. By doing this work we're doing here today, you're reminding everybody that meaningful change happens with one single voice, an idea, and the courage to share it. So thank you for allowing us to be a part of this journey. My name is Kimberly Mason. I'm 18 years old. I'm just finishing up my first year of college. I'm studying business administration. This is Nikaya Mason. She is 9. And this is Charisma Mason. She is 16. And we together are the Mason Hoop Dancers. We're proud Fisher River Cree Nation band members with family ties to God's Lake Narrows First Nation. And that's through our mother. And we've been dancing together for over 11 years now. So through our hoops as cultural performers and educators, we're proud and we're honored to be recognized throughout Turtle Island, which is also North America, for our contributions made towards reconciliation. Through our hoops, we've traveled all across Canada, from dancing in the mountains of British Columbia and through the prairies and the Great Lakes of all the different provinces, as well as going to the Yukon Territories in the summer of 2025. We've also competed all the way in Phoenix, Arizona, internationally at the World Championship Hoop Dance Competition for 2024 and 2025, and we've done some shows in the Pueblos of New Mexico. So through our hoops, we've traveled all over, and we're very thankful for the many opportunities we've had. But as far and as wide as we've gone, we still remain Manitoba's own. So we're very excited to be presenting to each of you the art of traditional hoop dance. It was the Honorable Murray Sinclair's words it was education that got us into this mess. And it is going to be education that will get us out. The education that got us into this mess refers to the historic ways that weren't working, like residential schools, the mistreatment of Indigenous families, their cultural practices and teachings, the mistreatment of each of our people and how they were taught to wrongly view Indigenous people. It even affected how we viewed ourselves. But we have the education that will get us out, made up of understanding and truth. Yes, there's still systematic racism. There's still barriers and challenges we faced as Indigenous people. But this education is focused more on learning from the past, by bringing together our communities and helping us learn together and celebrate the culture and celebrate the different teachings that make up our Indigenous people, highlighting us in a good way. So this third hoop represents you and me, Indigenous and non-Indigenous people. When we're able to come together, make relationships, make connections, and understand each other, opening our hearts, we are making our communities and our world stronger. So that's why it's important to have conversations like these today. Thank you.
This hoop here represents the circle of life. It's also our unity. It has no beginning nor end, and we all play an important role within the circle of life. Through the hoop, I've seen many different generations, many different age groups and cultural backgrounds, and it's truly beautiful. It's important for us to come together and open our hearts and celebrate one another.
So we're not just here today to hoop dance, but we're also here like you, each of you, in hopes to educate, to inspire, to bring together our communities and lift each other up through reconciliation and truth. And we're uniting and working together on this ongoing necessary journey.
Over the years, we've heard many different explanations of what hoop dancing is and what it represents. But only one thing remains. Hoop dancing is a storytelling dance that represents the story of life. The hoop is a sacred circle. We honor this circle as it represents the circle of life. The sunrise, the sunset, the world spinning, and the planets orbiting around us. This hoop is used in our everyday lives. For an example, if you watch very closely, you may see a hunter coming out of the tall grass, aiming and shooting her bow and arrow towards her prey. Or you may see an eagle coming out of its nest, stretching its wings, flying towards the bright golden sun. Hoop dancing is not just a storytelling dance, but it's also a healing dance. And that healing comes from the joy you get when you see the story unfold. So now we're getting into our dance of this afternoon, evening. And one thing we'd like to say is that your energy gives us energy. So feel free to clap, cheer, and be loud. This is Buffalo mixed with Redskin Girl. We hope you enjoy.
Yeah.
All right, thank you everyone for being such an amazing audience. We are the Mason Hoop Dancers. Feel free to follow our Instagram at Mason Hoop Dancers.
Hello, my name is Nakaya Mason. Thank you for having us here to share our culture with you. It is so important for us to share this knowledge with all of our different generations, like my sisters have done for me. Ego say thank you so much.
Thank you, Nikaya. And as always in our language, we don't say goodbye. We say we will see you again. So ego say, kino nas kumotin kitwam kawapamatin. Ego say, thank you.
One more hand for this group. Amazing. Just amazing. Thank you for being here tonight. Thank you, Elder Mead. And of course, Mason Hoop Dancers. My name is Mo Levy, Moses Levy, founding director of Idea Start, of course, at this university. It is a privilege to host tonight's evening with all our wonderful Falling Balls Manitoba partners. The vision for Idea Start was developed by our president and vice chancellor, Dr. Michael Benaroche. And it is my deepest pleasure, of course, to welcome him here this evening to bring greetings on behalf of our institution. Michael?
Thank you so much, Mo. And it's wonderful to be here. Thank you, Elder Norman, for starting us in such a good way. Thank you to the dancers. I'm not going to dance, you guys. But it's just wonderful to see everybody here and to have our community here. University of Winnipeg, as always, St. Boniface Research, and to all the judges, thank you for participating and for giving us of your time. And to the participants who have made it this far, congratulations. I'm sure you've worked really hard, and you know, we're really innovative in thinking of your ideas, and I look at the range of different ideas that are here, and it's really impressive. And it's great to have somebody from Regina here, and you know, well, you're always welcome here in Manitoba, just as long as the Rough Riders don't beat the Bombers. And you know, you know, Mo said that Idea Start was my idea, not completely my idea, but I believe the vision of bringing entrepreneurship to our universities, to our colleges, it was there already, and it's about bringing it together and ensuring that these ideas have an opportunity to go to the next step, that they don't just remain ideas, and that's maybe the idea starts here at university, and that's why we have the name, but that takes it further. And I think what we want to do is we want to add to the ecosystem here in Manitoba and see which are the next successful businesses that get launched through our university or the other public institutions here within our province. And so we've developed this amazing ecosystem in order to have that. And Falling Walls is a big part of the program, and it's driving innovation and driving it at the forefront of where we want to be as a society. And so it's wonderful to be able to have events like today. Also wanted to thank Research Manitoba, who's here, both saw Jennifer here, and then one of our judges, and Bioscience Association of Manitoba. Andrea, thank you for being here today. And you know, I think this is part of the reason why Manitoba does punch above its weight and why we're so focused on continuing to advance our province. I saw the Premier speak yesterday talking about really big ideas for our province, and these are big ideas for our university, and we're part of both trying to promote growth for Manitoba in Churchill and in other areas, and also how do we begin new ideas. And so that's part of what we're doing here. So I want to thank you all for being here and wish you a great evening. Thank you.
Thank you so much, Dr. Benarosh. This was such a wonderful start, and I know I'm not the only one who's kind of excited to get to the pitches as well. I bring regrets from the Honorable Mike Moreau's, Manitoba's Minister of Innovation and New Technology, who wasn't able to make it here tonight. And I also, unfortunately, the University of Winnipeg's President and Vice Chancellor, Dr. Gino D'Estasio, was also unable to attend this evening. And so while I am not the storyteller that Dr. D'Estasio is, as some of you may know, I did want to say a few words on behalf of my institution. Events like Falling Walls Lab Manitoba exist because of a simple yet powerful belief that the most important walls to break are the ones that stand between a great idea and the world that needs it. At the University of Winnipeg, that belief is at the heart of everything we do. We are a university deeply committed to research that matters, and not just in an academic journal, but in communities, in policy, and in people's lives. We believe that impact is not an afterthought to good research. It is the point of research. But impact rarely happens alone. It happens through partnerships between institutions, between disciplines, between researchers and the communities that they serve, which is why this collaboration in co-organizing this event means so much to us. It's a living example of what's possible when universities focus on the importance of building together. And so, no further ado, I invite you to now turn your minds to the walls that our participants hope to break tonight. And imagine 7,000 kilometers. That's the distance between Winnipeg and Berlin. Berlin, Germany, in case I didn't mention that. The winner of tonight's event will head to Berlin to compete in the Falling Walls International Finale with finalists from 60 different countries. But to get to Berlin, with travel generously provided by the Bioscience Association of Manitoba, tonight's participants first have to impress our judges. So this panel, esteemed panel, seated in the front here, consists of Joe Sear, President Emeritus of Price Industries Limited. Thank you for being here, Joe. Dr. Peter Nickerson, Dean of the Max Rady College of Medicine and Vice Provost Health Sciences. Thank you for being here tonight. Andrea Ladisser, President and CEO of Bioscience Association of Manitoba. Thank you for being here as well. Dr. Jeff Martin, Professor and Chair of the Department of Physics at the University of Winnipeg and past Tier 1 Canada Research Chair in Fundamental Symmetries in Subatomic Physics. Thanks for being here, Jeff. And last but certainly not least, Dr. Jody Dexter, Director of Intellectual Property at Research Manitoba, another key sponsor tonight. So thank you as well for being here. So just so everyone who aren't the judges know what's going to happen, our jury will be evaluating each pitch on 3 criteria. First, the breakthrough factor, which is how innovative or novel the idea is. Second, relevance and impact, whether the innovation provides deep impact with a small group or wide impact with a larger group. And third, presentation structure and performance. And there will be no questions after each presentation, but we will have a brief 30 seconds to a minute for the judges to have some time to actually write down all of their scores. So give them some time to do that.
All right, we are about to get started with the pitches of Prairie Changemakers, ready to break down walls in science, technology, healthcare, and human flourishing. Before we do, just 2 quick things. Here is a sense of how the evening will flow. We're going to hear from 6 presenters, and then we'll take a short pause for a musical interlude from the Finn Hogan Trio, and then we'll hear the remaining 5 participants. Then we're going to take a break for light refreshments out in the foyer. We'll enjoy some food together and an opportunity to visit. And during that time, the judges will be deliberating on this evening's winners. We are also going to choose an audience choice. So I want to invite you to take note of the pitches that impress you, and we will have a chance to vote before dinner. Before we start, though, Lauren and I wanted to say something to the presenters. The fine group of 11 folks at the back of the room there, we wanted to thank you in advance for sharing your ideas with us tonight. It takes incredible courage to get up on a stage. And it takes incredible courage to get up on a stage and share your ideas. And we're thankful that you are doing so tonight. And for all of us in the room, just imagine for a moment the years of work that have gone into the topics that they're going to share with us tonight. And they have only 3 minutes to inform and engage us. So we've given them a very tough task. But we want you to know, to each of you, that we are proud of you, that we are rooting for your success tonight and always. So would you join us in giving a round of applause for our presenters before we even start? All right, enough from my mama bear nature. Let's get started. We're going to start tonight by welcoming Dristi Roniar from the University of Winnipeg with Breaking the Wall Between Robots and Human Emotions.
In today's world, technology is advancing faster than ever, and robots have become an important part of this progress. But as we build these newer robots that help humans perform tasks with greater accuracy, speed, precision, and efficiency, we must ask an important question. Can these robots better understand the humans that are working with them? While a lot of robots help humans perform highly complex tasks, they are still unaware of the human operator's emotional state. My research aims at breaking this wall of emotionally unaware robots. In today's world, robots are being used in more and more fields like agriculture, manufacturing, medical robotics, advanced manufacturing, etc. My research focused more on medical robotics. Image-guided surgical robots are increasingly used in operating theaters due to the increased accuracy and precision that they offer. However, if we think of surgeries, in these highly complex environments, the surgeon goes through a bunch of emotional changes as well as a cognitive workload. Any small change in their mental state can affect or increase the risk of human error during these human-robot interaction tasks during surgery. However, current robotic systems are unaware of these emotional changes and cannot detect or respond to them. The increase in human error affects the surgeon's performance, the patient's safety, as well as the surgeon's own emotional well-being. My research aims at breaking this wall of emotionally unaware robots by introducing the use of EEG. EEG allows us to capture brain activity in real time and estimate emotional states such as stress, interest, engagement, attention, etc. Through my research, I was able to integrate a ROS2-based robotic system with EEG-based emotional signals, enabling real-time visual feedback. For example, if the human operator felt extreme emotional states such as highly elevated stress levels or dangerously low engagement levels, the robot was able to provide a real-time visual feedback to the operator, increasing operator's awareness as well as promoting a safer human-robot interaction. In surgery, this improves patient safety as well as surgery outcomes, but the same idea can be applied to any area that uses human-robot interaction. That's all for me. Sorry, thank you.
Thank you so much, Dristi. So next, we welcome Dr. Nitesh Sanghai from U of M with Breaking the Walls of Incurable Amyotrophic Lateral Sclerosis, or ALS disease.
Thank you. Today I can see a lot of smiling and hopeful faces. But imagine, one morning you wake up, you start dropping things. You are unable to speak, your words fall down, and you you are able to fall down in a stairs again and again. Your symptoms get worse day by day, and you get diagnosed with 3 painful letters called ALS. Ladies and gentlemen, amyotrophic lateral sclerosis is a disease which steals your time, mobility, voice, and your independence, while your mind remains completely awake. One of the major causes, oxidative stress, kills your neurons in your brain and spinal cord and leaves you with only one certainty called death. One of the famous personality recently who died because of ALS within 10 months. You know who? Eric Dane. Euphoria and Grey's Anatomy star Eric Dane. So what is the most important problem? The cases are rising. Every 90 minutes, somebody dies and somebody is diagnosed with ALS. Drugs don't reach the brain, meaning 98% of the drug which is available in the market, they are unable to cross the blood-brain barrier to save the dying neurons. Despite families spending $250,000 a year, most of the therapies available in the market, they cannot cross the blood-brain barrier to reach to the brain and spinal cord to save the neurons. Now I have a question for everyone. Can you fix a complex machine with a single screwdriver? No, you can't. So likewise, a single drug cannot treat a complex disease like ALS. That's why we came up with innovative solutions. We converted what we eat daily, which is called boron. Boron is a green chemical which we eat daily, 1 to 13 milligram per day recommended by World Health Organization. We converted boron into an innovative solution called bor-santrazole, which is recently trademarked and patented. Bor-santrazole first will act as a fire extinguisher to extinguish the oxygen fires in the brain. Secondly, bor-santrazole will convert into edaravone, which is an ALS existing drug, which is an FDA approved drug.
Thank you, Nitesh. Great job. Next, we welcome Mehdi Abid from the University of Regina. Welcome with Breaking the Walls with AI tools for early crop disease detection.
A leaf changes color, a spot appears, and the crop started to look unhealthy. But knowing what to do, it might take 1 to 6 weeks. And during that time, crop does not wait for anyone. It keeps changing. Around the world, plant disease and pest destroy nearly 40% of the crop production, and it costs nearly $220 billion every year. But for a grower, this global problem has one question: what should I do now? They started to search online because today the traditional process is often slow. They send photos for advice. Sometimes they wait for the lab results. But this process cannot save the crop. Then how am I going to save it? That's why my research comes in AgriVision AI. AgriVision AI is going to build the change of the timing. It's going to help the farmers with the early detection signals. It's going to help the farmers to save the crops early before it reaches to the empty shelf. AgriVision AI is going to, when the growers take a photo of a problem plant, is going to give 3 signals, 3 answers. What might be the wrong, how much serious it is, and what should I do next? Because the real value, when I spoke to the community of the grower, I have learned that these types of delay might take 7 to 42 days. One of the growers even mentioned they lost 75% of their crop just because the lab result came so late. That's the high price of a crop productions. So to save this, my research idea is going to help with the farmers, with the growers, and we're going to focus on the greenhouse community. Because it's high value and time sensitive nature. According to the 2024 Canadian data, a greenhouse produces worth about $2.7 billion. And its exports reaches about $1.97 billion right now. So even if we can save 1% of the crop, that would be worth about $27 billion. Around the world is going to be then $2.2 billion. So that's why my research matters. That's why the traditional research is slow, traditional process is slow, and AgroVision AI make it simple, better, and faster. Thank you.
Thank you so much, Mehdi. So next, we are going to welcome Sebastian Sanchez from with Breaking the Wall of Mining Waste through Biomining. Welcome.
Okay, thank you for the introduction. Again, my name is Sebastian, and today I want to talk to you about breaking the wall of mining waste through biomining. The mining world faces a paradox. More rocks need to be mined to obtain the same amount of metal. In just over a century, the grade of metal ores has plummeted 2 to 10-fold. But meanwhile, the race for modernization never stops. And today, more than ever, sectors like artificial intelligence, renewable energies, defense, and countless others are driving an ever-growing demand for metals. Copper is a great example. By 2050, we might have to mine as much as we did for the past 125 years just to meet demand. And we all know what that means. Bigger mines, more energy consumption, and especially far more waste. And this is no small matter. Mining activities around the world already produce about 100 billion tons of solid waste, which is a bit over half of Mount Everest, every year. And there's a specific group of minerals, sulfides, that are intensely being mined for holding many of the key metals for modern industry. But as their mining waste builds up, so grows another problem. They all oxidize, releasing acids and heavy metals into water bodies and neighboring communities, not for decades, but for centuries. This waste isn't garbage in the conventional sense, though. It still holds significant amount of valuable metals, albeit too diluted or not in the right form to be processed. The world requires of innovation, and here's where Vivo Ore comes in. We are harnessing microbes whose appetite for sulfides rivals ours, in a more literal sense. They eat them. Through a process called biomining, these microbes can turn millions of tons of dangerous waste into an untapped leftover treasure. And here's how it works. First, we sequence all of the DNA in mining samples to identify which microbes call those rocks home. If we find any promising candidate, we try to grow them and put them into groups tailored for the task. Think of them as a rock band, each of them playing a role to create a groundbreaking performance. Finally, we put them into optimized bioreactors, feed them the mining waste they came from, and obtain a wide variety of metals, as well as stable forms of common contaminants like arsenic. With extraction efficiencies often over 90%, we're not just recovering metals, we're physically removing contaminants from the environment. Even better, byproducts of biomining, like acids and solids, can be repurposed in the production of fertilizers and building materials, contributing to real circular economies. As I said, today more than ever, we want more computers, satellites, medical devices, and a myriad of other technologies to live a more sustainable, healthier, and comfortable life. But as the consequences of our actions grow to the size of mountains, it becomes harder to turn a blind eye. With Vivo Ore, we want to show that some of our largest problems might simply require microscopic solutions. Thank you.
Thank you, Sebastian. Okay, next we welcome Lena Reggie Sulith with Breaking the Wall of Heart Transplant Rejection.
Look around you. 1 in every 5 people in this room is at the risk of having heart failure. That's 20% of the global population, with heart transplantation being our only life-saving option. Now, imagine your neighbor with end-stage heart failure. They wait for months, sometimes years, for a donor heart. And finally, one day they receive it. But the moment the new heart begins to beat, the immune system starts attacking it. Now, modern medicine does something extreme to tackle this. It suppresses the entire immune system using lifelong immunosuppressive drugs. This makes the patient vulnerable to other diseases, infections, side effects, and a series of consequences that makes their second chance in life into a lifelong battle. And this raises an important question. Are we solving the problem in the right way? What if, instead of suppressing the entire immune system down, we teach it what not to attack in a localized way? This is exactly what my research does. Using a revolutionary innovation called nanotechnology, I design and create safe nanomaterials called mexines that can re-educate the immune system. These materials are so small that 1,000 of these particles could fit across the width of a human hair. My nanomaterials also have unique surface properties that allows them to travel through the body with precision, attach to the immune cells, enter them, and specifically reduce the aggressive cells that cause rejection and increase the protective ones that bring about tolerance in a localized way. Next, testing them in an animal model in rats that mimics the clinical scenario, we can see that my nanomaterials extended the life and the survival of the transplanted hearts threefold. Today, my research starts with heart transplantation, but its impact could extend far beyond to other organ transplants and immune-related diseases, making it a universal strategy for localized immune modulation. Because ultimately, it's not just about that neighbor or 1 in every 5 people in this room. It's about all of us having a future with one nanomaterial platform, one localized immune solution, and a second chance in life that is not fragile. And that is the promise of my research. Thank you.
Thank you so much, Lena. Next, we welcome Robina Gosel from the University of Winnipeg with Breaking the Wall of Fertility Treatments.
Hope is a quiet thing. It sits in waiting rooms, it's whispered in prayers, and it's a single pink line in tests that should show 2. Infertility impacts 1 in 6 families in Canada alone. Of those families, 30% of cases refer to anovulatory infertility, which happens when women are not ovulating consistently. There are many reasons why someone can develop this type of infertility, but scientists often attribute it to the improper functioning of a protein in our body called the follicle-stimulating hormone receptor, or FSHR. A common treatment to overcome anovulatory infertility is IVF, which involves the injection of hormones to help aid in conception, and it works. But a single round of IVF can cost up to $20,000 in Canada and involve up to 90 injections. Not only is that incredibly mentally and physically demanding, it is simply not affordable for many families, especially in the current economy. Scientists have been trying for decades to develop fertility treatments that can be given as a pill instead of a needle. But because other proteins in our body are very similar to FSHR, it makes developing targeted drugs extremely difficult. But that's where my research comes in. I use drug design techniques to identify compounds that can selectively target FSHR. I look in the Pan-Canadian Chemical Library, which is a new database, and it features molecules that are being studied in Canadian university labs like mine. Using theory that is actively still in development, unsurprisingly, goes underutilized, but it offers the chance to study unique molecules, which is an untapped potential waiting to be explored. But I don't just search for promising drugs, I build them too, using rearrangement reactions. Have you ever bought a Lego set? Just because you bought a pack to make a flower doesn't mean you can rearrange those blocks and make, say, a butterfly. Rearrangements are also environmentally friendly because I'm not buying more Legos to turn my flower into said butterfly. That's what I do in the lab. I take a molecule and I change its shape to become something more useful. I build up molecules to break down barriers in accessible fertility care, to give people something more to hold on to than hearing just keep trying. Science is about problem solving. It's about persistence. And it's about people and changing the way we live. I don't have all the answers to infertility, but what I do have is the opportunity to find some. Because when we push the boundaries of what we know, we don't just change molecules, we change futures. Thank you.
Thank you, Rabina. What a terrific start to tonight. How about we give our first 6 presenters another round of applause? Yes. Okay, before we carry on, we're going to take just a short break to hear from the Finn Hogan Trio. Let's enjoy this short musical interlude from students from the UM's Des Hotels Faculty of Music. Welcome.
Thank you so much. Let's give another warm welcome to the Finn Hogan. Okay, we love, and when I say we, I mean all of us here, I'm sure, love celebrating students' learning, research, and creative works. So I'm going to give organizing folks 1 second. Before we go, we're good to go? Okay. So I am now, for the second half, I'm going to welcome our next participant. So please welcome Dr. Saba Mohammed Alinazad Koladuz from UM with Breaking the Wall of Stroke Recovery at Home.
Let me ask you something. How many of you know someone who has had a stroke? Maybe it was a parent, a grandparent, a friend. One day, they could hold a cup of coffee, button a shirt, hug someone they love. And the next day, they couldn't. That's because after a stroke, the connection between body and brain can suddenly break down. And this is a reality that millions of families face around the world. But movement is not just all about muscles. Movement depends on communication between body and brain, that after a stroke, the brain no longer receives clear sensory information from the body. Imagine reaching for something in complete darkness without fully knowing where your arm is. That's sad, but this is how a movement can feel for millions of stroke survivors. The problem can even become more critical after a person leaves the hospital, because first 3 months is the most critical window for brain recovery, yet many stroke survivors receive less to no rehabilitation supports after hospital discharge. Yes, there are some rehabilitation options out there, but currently, rehab systems mostly focus on output. Like, did the arm move? Did the patient complete exercises? The same approach is often used for everyone. But at SynapPlay, our venture, we focus on input. Because the brain cannot relearn movement effectively if it cannot properly feel it. SynapPlay is a neurorehabilitation platform that combines interactive rehabilitation exercise with a wearable wrist device that delivers sensory information during movement. Every time a user reaches, the wearable device sends sensory signal back to the brain in real time at a level that actually patient can feel it, trying to restore missing communication loop between sensation and movement. And while patients train at home, our platform continuously monitoring movement quality, allowing clinicians to remotely personalize therapy in a most critical stage of the recovery. So, this is not just another wearable device. We are redefining rehabilitation from exercise training to brain communication. The impact, more independence for stroke survivors, less burden on caregivers, and a rehab that goes beyond hospital walls. This is SynapPlay, helping stroke patients reach again.
Thank you, Saba. Okay. Next, we welcome Wasim Ahmed from the University of Manitoba with Breaking the Wall of Training in Industry and Healthcare. Welcome.
Thank you. Imagine you are in a situation where you have to take a decision in a second, and knowing that one mistake can permanently injure you. And now imagine there is no one beside you who can guide you or help you. This is happening with the millions of workers who work in industry. Around 3 million people die due to work-related causes. And at the same time, the expertise that could prevent this is disappearing. Across Canada and Europe, around 2 million skilled workers retire every year. And yet, those who remain are still expected to perform complex tasks without any supervision. And remember, when there is no supervision, the preventable mistake can become a life-changing injuries. This is the wall we need to break. Now look at this worker who is alone, confused, nothing know what to do, and making all the decision on his own. And one mistake can lead to a costly errors or even injuries. Now imagine if we simply put this augmented reality AR glasses, and instead of searching manuals, he get the guidance instantly. So our model, augmented reality AI solution, read the manuals, interpret the errors, HMIs, and understand the user action. And it also monitors the user action, whether it's doing right and wrong, and provide instantly guide at the right time, and when it is needed. Like a Jarvis, if you have seen the Iron movie, but that was a science fiction. Today, we tested and built it on real industrial machine. We have achieved 99% accuracy and guidance with that solution and reduced the workload of user by 51%. That means low chances of error occurred while using this AI supervision solution. And if this solution is deployed at a scale, it has the potential to prevent 234,000 fatalities that are caused by the worker errors. And unlike human expert, this is available 24/7, never retires, and update anytime. Today, we tested it on industrial machine. Tomorrow, it can support the healthcare. Like doctors need surgery, doing surgery and need the guidance, it can help there. And the pharmaceutical industry, where compliance are followed strictly. Because we believe that expert guidance should be available anywhere and anytime. And that's all. Thank you.
Thanks so much, Wasim. Next, we welcome Rudra Patel from with Breaking the Wall of Blood Cancer Prognosis.
Imagine going in for a routine blood test and getting a call back just to hear the words, "You have blood cancer." But when you go see the doctor, instead of starting your treatment immediately, you're told to wait. Not days, not weeks, but indefinitely. No action, just wait and watch to see if or when your blood cancer gets worse. This is exactly what happened to my grandmother, and is currently happening to thousands of patients across the globe suffering with the most common type of blood cancer, chronic lymphocytic leukemia, or CLL. About 1.2 million people every year are diagnosed with blood cancer, and a third of whom with CLL. Doctors want to treat these patients, but often can't because not all patients are going to progress, and chemotherapy can do more harm than good. So instead, all these patients are told to wait and watch, a phrase better described as wait and worry. A 2023 study showed that patients who are stuck in this limbo experience scored significantly lower in their mental and emotional well-being. And honestly, who wouldn't? CLL just doesn't take toll emotionally on these patients and their families, but it's also a huge burden on our healthcare system. So at Cancer Care Manitoba, we asked a question. Can we give these doctors and patients a better answer? With one clear mission in mind, a team came together, led by a clinical oncologist with decades of experience and a DNA damage response expert. Our lab identified a strong predictor of CLL progression, a protein called phospho-DNA PK. This led to development of Clarity, a simple, fast, and a low-cost test that uses a technology called flow cytometry. After testing multiple live patient samples from Manitoba Tumor Bank, we observed a trend. The level of phospho-DNA PK in these patients' blood directly correlated to how aggressively their cancer was progressing and when they will need treatment. So instead of anxiously waiting for months, patients and doctors can make decisions about the treatment right at the time of diagnosis. Decisions that are also statistically significant and data-driven. So currently, I'm testing different kits to find the perfect match. The one that has better chemistry, is widely available, and is compatible with our existing hospital infrastructure, so we can scale this up for real-world use. So everyone, my grandmother got her treatment just in time. But when we finish this competition, there will be 80 more loved ones still anxiously waiting for that life-changing phone call. So with clarity, we're changing wait and worry into confidence and clarity and breaking the wall of blood cancer prognosis. Thank you.
Thank you, Rudra. Next, we welcome Anis Ul Hossein Ahmed from the University of Manitoba with Breaking the Wall of Missed Defects in Critical Infrastructure.
Let me ask you something very simple. How does our home warm during the winter time in Manitoba? The natural gas. How this natural gas comes to our homes? This natural gas comes from all around the Alberta and comes through from the oil and gas pipeline and then comes into our homes. These natural gas pipelines are around the world, and approximately more than 1.18 million kilometers of gas pipelines right beneath our homes, right beneath our schools, and all of the world. This is something is different. So these pipelines are made of carbon steel and different materials, and these materials are tired with the passage of time. So once they are tired and once they are damaged, we need to inspect them. So periodically we are doing our inspections to find the defects, find the critical infrastructure passages. We need to do some kind of inspections. We have a tool that is called phased array ultrasonic inspection. This tool is utilized as an ultrasonic wave propagate into a material and find the defect without causing any damage. But the thing is only, we have do our inspections, but without inspection, we are getting damages. And if we are doing our inspections, this kind of failures that happen. In California, 2010, the gas pipeline that was just beneath our home was burst and it kills 8 people. And the same thing happened in Taiwan as well in 2014. 37 people were killed because of a gas pipeline was burst. To detect the defect in the gas pipelines and the other assets, we are using phased array ultrasonic inspections. But the thing is only, the data produced from this PAUT machine, the phased array machine, is very difficult, right? So the problem is came whenever we are doing our inspections, we need to utilize some kind of informations that is used by humans, and human analyze them and then generate their results. But the thing is, humans get tired, right? They can confuse because that images are very complicated, and these images can cause a damage and be a very catastrophic failure. If we miss one defect, definitely it will be a worst. At University of Manitoba, we developed one method that called MVE, Multi-View Evidence Integration System. This is one of the core point, which is replace that same scenario of human that interpret the damages from the inspections files. So everything that is under the files, we are utilized. So with the traditional methods, it doesn't require any kind of training data. It doesn't require anything. So it's fully explainable, and we can got the idea. Thank you so much.
Thank you so much, Anis. Okay, so we're welcoming our final participant of the evening. I want everyone to help me welcome Ishadi Namir from the University of Winnipeg with Breaking the Wall of AI Hallucinations.
Imagine looking at Earth from space. A satellite captures an image of a firm land right after a flood. Now, let's assume we have an artificial intelligence or AI system, and we ask it to just describe that image. It replies confidently, a major highway runs through a busy city. But in reality, there is no highway, no city, just a flooded farmland. This is called AI hallucination, when a system sounds so convincing, but in reality, things are simply not there. In social media, this kind of hallucination problem might not bother us that much. But in case of satellite imagery, it matters, because describing satellite images accurately is extremely important in fields like climate monitoring or tracking natural disasters. Now, let's try to understand why this problem happens. Unlike everyday photographs, satellite images are much harder for AI to explain. The objects in the satellite image might appear in different scales or angles, and sometimes the important details might be very subtle. For these reasons, the existing AI systems often rely too heavily on the language patterns than on what they actually see. My research focuses on breaking this gap between what AI says and what it actually sees. At first, I trained the AI system with both the satellite images and their description using a method called contrastive learning. In simpler terms, the AI system constantly compares the satellite images against its matching and mismatching descriptions so that it can learn to pull the correct pairs closer together and push the incorrect pairs far apart. Over time, it creates a shared understanding between the text and the image. After that, while generating description for the unseen satellite images, I guide the AI system with an additional alignment step. And this step constantly keeps asking, are these words really supported by the image? If the system starts to drift, if it begins to imagine roads and highways that are not present in the image, the alignment penalty pushes it back towards its correct visual representation until the final correct description is generated. As a result, the system is not only fluent, but it stays grounded in reality. This AI system can help to analyze a large number of satellite images within a very short time during floods, wildfires, or other natural disasters so that the responders can quickly identify the damaged areas and help people where needed. Ultimately, my goal is to make the AI system say what it actually sees, not what it thinks should be there. Because when we take help from machines to understand the planet that we all share, truth should never be replaced by hallucinations. Thank you.
Thank you, Ishati. And could we give a round of applause to all of our presenters? Well done, each and every one of you. Thank you. All right, before we exit to the foyer for refreshments, you are going to see on the screen in just a moment a QR code. Right, Ritesh? Okay, and on that QR code is a link with the names of all the presenters, and we'd like to invite you to have your voice heard and to choose your audience favorite. As we head out into the foyer, we're going to enjoy some food and some company with one another, and we're going to come back into this room in about 45 minutes or so. Fantastic. Thank you, Ritesh. Wonderful. Have your voice heard. Enjoy dinner. We'll see you back in about 40 minutes.
Is everyone ready? Thank you for your patience. Welcome back. I hope you enjoyed the food and the conversations. And a special thank you to the jury who was still working very hard during the break. We understand they've made their decisions, so we are going to move to the awards. Before we hand out even a single award, though, how about another round of applause for each participant? First up is the Audience Choice Award. So before we invite up the presenter,
Hi, I'm Daniel.
We're going to see a video. And a special thanks to the Faculty of Science at the University of Manitoba, who's presenting this award, but also producing these beautiful awards that we're going to be handing out. So this video is a little insight into how the awards were created.
Hi, I'm Daniel from the Faculty of Science, and right behind me here is the Faculty of Science's Makerspace, where we created this year's Falling Walls trophies. Every year, the Faculty of Science hosts the 3K pitch competition. And this year, IdeaStart was one of the event sponsors. After seeing the trophies that were being given to the winners, Rajiv reached out to me to design trophies for the Falling Walls pitch finale. IdeaStart being an interdisciplinary hub for collaboration, I thought it would be reasonable to bring in another faculty to support the development of these trophies. So, luckily, I reached out to my friends at Architecture, who were able to provide us with the materials and the CNC routing to develop these trophies. This is Manitoba Elm. That was an offcut from an architecture project. So not only is it a waste product, but it's actually made in Manitoba. Once we received the blanks from architecture, we took our designs and put them into the laser engraving software in the makerspace here. From there, all we really needed to do was put the blank into our laser engraver and press a button. Once that was all finished, then we had our nice trophies all ready to go. Best of luck to all Falling Walls finalists. You put in a lot of work to get here. I can't wait to hear your brilliant ideas. So just live in the moment and take it all in.
Okay, so I'm going to invite up Robert Vanette, who is the Business Development Officer in the Faculty of Science, to present this award. And after all audience votes were tallied, we're delighted to give the Audience Choice Award to Wasim Ahmed.
Okay, we would now like to invite Dr. Bram Ramjivan from St. Boniface Hospital Research to present the third place award. And thank you again for your partnership in Falling Walls Lab this year. Congratulations to our third place winner, Rudra Patel.
Congratulations, Rudra. We now invite Jennifer Cleary, President and CEO of Research Manitoba, to present the second place award. And congratulations goes to Sebastian Sanchez.
Okay, here we are. First place, which includes travel to Berlin in November, provided by the Bioscience Association of Manitoba, and a prize from Research Manitoba. We welcome Dr. Mario Pinto, Vice President of Research and International at the University of Manitoba, to present the award. And we'd like to invite you, Andrea, to come up as well to give that boarding pass. All right, the first place award heading to Berlin to represent Manitoba. Saba Mohammed Alinazad Kaluaduz. Congratulations again to all of our participants this evening, and a special congratulations to you, Saba. We are absolutely delighted to see you represent Manitoba in November. To close our event, all that remains is to thank the many people that are needed to put on an event like this, and to do so, I welcome back Dr. Mario Pinto.
Well, thank you very much, Janine and Lauren. It's been a great evening. And thank you all. I was a bit underdressed, HJ thought, and so he made me wear his tie. This is true story, true story. So first, please join me in celebrating all of the Falling Walls finalists who presented here tonight. Well done. Each of you has obviously made an important mark in knowledge translation, not only here this evening, but in your lives. And I look forward to what the future is going to bring. Right? So please join me once again with a round of applause. And our members of our jury had a daunting task, but let me also thank them, right? Joe Sear as chair, Peter Nicholson, Andrea Dessert, Jeff Martin, and Jody Dexter for your very challenging selections. I don't envy you your tasks there. I hope you got something to eat. But, so the growing collaboration in Falling Walls, Manitoba now includes Ideas Start, Brandon University, University of Winnipeg, University of Manitoba, and the St. Boniface Hospital Research Foundation, including pitch coaches and reviewers from University of Winnipeg and the University of Manitoba. I also want to express my deep gratitude to the advisory and organizing committees for Falling Walls Manitoba and all our volunteers. Well done, Mo. You've done a great job here. Yeah. Thanks to all for your hard work on this event. The event is quickly becoming the highest profile pitch competition for breakthrough research ideas in the province. UM is committed to providing wraparound support for all members of the Manitoba research ecosystem through Ideas Start, which offers targeted programming to transform ideas into real-world impact right here at home. I would also like to acknowledge special guests. Even though they couldn't be here, I think it's important that I state they intended to be here. The Honorable Mike Morose, Manitoba's Minister of Innovation and New Technology, and Rebecca Molinoff, the U.S. Consul in Winnipeg. They sent their regrets. I thank Elder Norman Mead and Dr. Gino DeStasio, who couldn't be here, from the University of Winnipeg, also for their contributions. And thank you for joining us for this glimpse of future innovation in our community. I think you will agree that the future of Manitoba is in good hands. So let's clap to that. So the event has also benefited from the generous support of the event sponsor, Research Manitoba, who has been very good to us in matching things like the CFI program, and we hope that will continue in the future, Jen. So. No pressure, no pressure. Their travel sponsor, Bioscience Association of Manitoba. Thank you, Andrew. And trophy sponsor, the Science Innovation Hub at the UM Faculty of Science. Thanks very much. So let me tell you what's coming. So thanks to the leadership of HJ, let's give HJ a hand, and his tie, which is playing well, there is a plan to expand the footprint of Falling Walls this year to coincide with the celebration of 75 years of diplomatic relations between Canada and Germany and 55 years of scientific and technological cooperation between the two countries. In addition to the competition for best innovators, which will take place in Berlin, to which we're sending our winner, the Canadian federal government, through ICED, is considering sponsorship of a pan-Canadian university presence, a Canadian pavilion to highlight Canadian innovations. This initiative is the brainchild of Andreas Kosmider, Managing Director of Falling Walls, and our own HJ. So we hope it comes to pass. We're in heavy negotiations at the moment, but it looks good. It looks very good. So with that, ladies and gentlemen, it leaves me, on behalf of the University of Manitoba and the other participating universities, to thank you for your participation here and your presence here tonight. So thank you, drive carefully, and have a wonderful night. Yeah.